You ready?
It's recording, yeah.
Okay, cool. Alright, so what we're doing is we're going to be calculating velocity and average speed, I should say average, from a displacement time graph. Okay, so we've done this as a calculation, which is velocity equals displacement over time, yeah, if we go back a few lessons. So we just have to have a look at this. Alright, so just to remind you, what's happening in this section here, section A? Someone wants to help me out?
Speeding up.
No,
It's not speeding up, Igor.
he's just going at a pace.
Yeah, he's going at a constant speed. Yeah, close. Speeding up would be like that. It would start off really slow and then speed up, yeah? But we're going at a constant speed. We've gone 20 meters in 5 seconds. Yeah? Yeah, exactly right. How did you do that, Igor?
20 divided by 5.
Exactly right. Okay, so this is all we have to do. It's just a little bit of maths, okay? In this case, we'll say velocity equals 20 divided by 5, which equals 4. And we want to use our units. We've got meters and we've got seconds, yeah? Does that make sense, guys?
Yeah.
Okay. This one, we don't really have to do any fancy calculations. What can we say the speed is here? 0, yeah? This is 0 meters per second, okay? And this one, before you even do the calculation, is going to be positive or negative?
Negative.
It's negative, yeah? It's pointed downwards, okay? So that's just a bit of food for thought, okay? Let's have a look. So we know it's going to be negative, so I'll just put a little minus there just to remind myself if I get the units wrong. We start at 20 and we end up at 15, so it's 35, yeah? You guys following me?
Yep.
So just go velocity equals 35 over, was it 5? Yeah, it's negative 35, yeah? Negative 35. So that means our velocity is negative 35 divided by 5, which is
7.
Yeah, good. Negative 7 meters per second. Okay? So it's just a little bit of maths there. And again, and you could do this in the test if you've got the time, yeah? Okay? You could just double check. You could have a look at this and say, well, if I'm going at 4 meters per second, yeah? Work the other way around. If I go 4 meters per second for 5 seconds, yeah? It'll be 4, then 8, then 12, then 16, then 20, right? That's in 5 seconds, ended up at 20. Okay, that makes sense, yeah? I've made sure the proof works, okay? Does anyone have any questions about that one? Does anyone know what we do, right? Because I've got rise, 20, over run, which is 4. Does anyone know what that's called?
Gradient?
Gradient, yeah. This is actually where gradient came from, I think, right? I believe Newton came up with a term, yeah? So that's just a fancy way of saying gradient. You guys would have learnt this in Year 9. You probably didn't understand what the purpose was. I think the original purpose of calculating gradient was just for calculating like velocity or displacement and that kind of thing. Okay? Now, for something like this, okay, and the question, if I gave you a specific question, it would ask calculate velocity for this, or calculate, in this case, average speed. Why do I want to calculate average speed for this instead of velocity?
Because it's like all over the place.
Yeah, it's all over the place. If I was going to try and calculate gradient, and you can for curves and stuff like that if you're doing Year 11 or 12 methods, right? But we're not doing that. You would have to grab the gradient here, then here, then here, then here, then here, and build them all up, okay? And that's impossible, okay? It's going to take too much time. So what we can do is we can do average speed. So first of all, who's winning the race here?
The first, the squiggly line. The really squiggly line.
Is it this one or this one? First one, yeah? They've reached 20 meters in 10 seconds, yeah? This one here. This person's done 20 meters in 20 seconds. So let's do average speed. In this case, 20 meters in 10 seconds, right? Let's put it over here. That equals what? 2 meters per second. That's the average speed. Yeah, average speed. They could have gone really, really slow to begin with and they speed up and they slow down, but over that 10 seconds, the average speed is 2 meters per second. That's what it means by average, okay? And in this case, this is going to be 20 divided by 20 equals 1 meters per second. And that's why they're slower, yeah? That's why it's taking twice as long to get the same distance. Yeah? Okay. That's it. Thank you, Sean.